5 seconds if you want to guess. Guessing probably messes up your chances of 7th place, but... So, calculating the face area of a retaining wall, and this is the exposed face area, not accounting for anything below ground, which I think is typical for us. There's a few ways to do it, but my favorite method is using the quick profile. So if I grab these feature lines and evidently just grab one. So I'll grab the bottom of the wall and go to quick profile. I'll let it profile the EG. I don't care about my grading groups. And then down here, it's also going to draw the 3D entity profile of the object I selected. So we'll switch that one to a different style. And then select an insertion point. So there's the profile of the bottom of wall. And then if I want to add another profile to that, select my profile view or the grid, and then from the ribbon, project objects to profile view, and go ahead and add my top of wall. And I'll just accept the defaults. This probably won't draw it real pretty, but it'll do what we want. So that's a look at the face of the retaining wall. The bottom of the wall actually follows existing ground, and the top of the wall has whatever, this shape. So now, if I just want to calculate areas, I'll just explode these, get rid of my little markers. I could have adjusted my style so those markers were not there. And then one of my favorite commands is LineWorks shrink wrap, and select those, and it shrink wraps it with a polyline. So that polyline tells me the area is 3,200 square feet. However, my profile view settings are distorted by a factor of 10. Almost all of our profile views by default are going to be distorted by something. So if I go into my edit profile view style, I can verify that vertical exaggeration is 10. So I'd have to divide that 3,200 square feet by 10 to get the correct area. Quick profile is definitely a top 5 command of mine. I love
Robert.
Yeah.
Yeah, I did it a little different way. I don't know if it's, real world practical, but I just took the 2 break lines, added them to a surface, and then went into the surface properties and looked at the 3D surface face.
Yeah, that's definitely a good approximation. I'm curious how good. Like, what'd you get for an answer?
The right one.
Within a couple feet, or?
Yeah, here, let me tell you exactly what I got. I got 3D surface of 320.96. I think the correct answer was, what, 325?
That's good enough for me. I'd take that. If you want to dial that in a little bit more, you would take these guys and move them closer together so that it's modeling almost truly vertical.
Right.
This is how I usually model walls, is put a foot in between them, or whatever I think of the width of the wall would be. So that's throwing off your 3D a little bit, but I think that's a good method. And for doing a lot of walls, it's probably faster. So, yeah, it should work. And like we were saying before when we were doing surface volumes, you just want to do some form of a sanity check. So if I want to do a sanity check on this, I'll just bounce along here and pull a distance. So the delta Z there was 0.2, and the delta Z here is 2.69, which is, exactly what I'm seeing right here with my tracker. So if just at these 4 points I did a triangular estimation, that'd be a worthwhile sanity check, and probably close enough for answering the question too.